lesson focuses on solving exponential and log equations. We'll spend 2 classes working on this. Today we want to focus on the easy ones that we can simplify through some exponential and log properties. So there's 2 properties we need to focus on. First is the one-to-one property. So this says if you have a to the x equal to a to the y, then those exponents, x and y, are equal. When you have these like bases, you can basically drop them. Same thing works for logs. Log base a of x equals log base a of y. We can take those values, x and y, and set them equal to each other because we have like bases. So let's go ahead and actually start solving. If you have an exponential equation like 3 to the x equals 3 to the 4th, we want to solve for x. Since we have like bases with our one-to-one property, we can drop those out and we end up with x equals 4. My exponents are equal, x equals 4, and that's it. That won't always be this easy. Sometimes we have to do a little extra step and rearrange some things or rewrite some things. For example, here I have 2 to the x equals 1 over 16. I know some of you can probably do this in your head using the numbers. If you can, that's fine. But just to illustrate the property, with our like bases, 2 to the x equals, now instead of 1 over 16, if I want to cancel out my like bases, I need to rewrite 1 over 16 as an exponential term with base 2. So 2 to what power gives you 1 over 16? Negative 4. Now I have my like bases. I can drop those and set my exponents equal to each other. So x equals negative 4. Again, if you just did this in your head, that's fine. I just want to illustrate the property. All right, let's take it up a notch. 2/3 to the x equals 81 over 16. So we want to rewrite this term in terms of my base 2/3. So I can drop those like bases and set the exponents equal to each other. So 2/3 to the x equals, well, how can I rewrite 81 over 16 as an exponential term with a base of 2/3? 2/3 to what power gives 81 over 16? Again, just by coincidence, we end up with negative 4. So since I have like bases, those drop out. I can set the exponents equal to each other. X equals negative 4. Last example for the one-to-one property. Like I said, it still works with logarithmic expressions as long as you have like bases. So log base 2 of 4 equals log base 2 of x. Because I have a log expression with like bases on both sides, I can set whatever I'm taking the log of equal to each other, which ends up giving me the value x equals 4. Next property, oh, just kidding, we're still going. Like I said, it won't always be this easy. Sometimes we have to do some rearranging. So here we have the natural log of 3 minus the natural log of b equals 0. Well, to use our one-to-one property, we need like bases on each side. So I see with my natural log, I'm going to have base e and base e, but I don't have them on either side of the equation. All we're going to do is just scoot it over. Add the natural log of b to both sides. So we end up with natural log of 3 equals natural log of b. Now that I have like bases with my log expressions, essentially base e and base e, I can drop those to find b equals 3. Last one for real this time. For our one-to-one property, log of x minus 3 equals log of 10. Do I have like bases here? Yes, remember counting log is base 10. So those can go away. I can just set what I'm taking the log of equal to each other. In other words, x minus 3 equals 10. Easy peasy, solve for x. X equals 13. So that's how we use the one-to-one property. Alright, continuing on with our next property, we have what we call the inverse property. Remember, this is how exponents and logs are related. They're inverses of each other. Well, what do inverses do? Think about your inverse operations, adding, subtracting, multiplying, dividing. Same concept happens here. Our inverses cancel each other out. So if you have a to the log base a of x power, those are going to cancel, and you're left with x. Same thing the other way. Log base a of a to the x, those things cancel, and you're left with x. So to put some numbers to this, for example, we have 4 to the log base 4 of 7. Like bases, cancel out. 4 to the log base 4 of 7 is 7. That's all we got to do to simplify. Cancel that out. Next one. E to the natural log of 4 power. Well, what's the base for natural log? E. What's my base here? E. Like bases cancel. That simplifies to 4. Now last one. Make sure we're being careful. Just because we see something raised to an exponent that has a log term in it doesn't always mean it cancels. Here I have exponent base 3 in my log expression. I know it's blurry, but that's base 2. Are those like bases? No. So don't just start canceling just because you see something that looks like that. It has to be like bases in order to cancel. In other words, we're saying 3 to the log base 2 of 8 power. Well, what is log base 2 of 8? In other words, 2 to what power will give you 8? 3. So it's really just asking you for 3 cubed, which is 27. So just be careful, make sure we're reading carefully. We have to have like bases. Just wanted to throw that in to make sure that we're being careful. Right, next one, let's simplify. Log base 4 of 4 cubed. Like bases, cancel out for my inverse property. I'm left with 3. Simplify. Next one. Natural log of e squared. What's the base for natural log? E. Base e and base e will cancel. I'm left with 2. Just using my inverse property. So when it comes to actually solving these equations, we want to make sure we're isolating that exponential or logarithmic term. And sometimes we may need to just rearrange or rewrite things in order to get it to a form where we can use those formulas, or properties rather. So once your exponential or log term is isolated, you do whatever rearranging and rewriting that you need. You go ahead and cancel stuff out. Take the inverses of both sides. So if you have an exponential thing, you're going to take a log to cancel it out. If you have a log thing, you're going to make it exponential to cancel it out. Then you just go through, continue to solve as you need to. So our first example, e to the x equals 7. We want to solve for x. Well, x is up in the exponent here, so I need to get it back to ground level. So that's where these steps come into play. First, I have base to the exponent. My exponential term is already isolated, so no extra rearranging or isolating needed there. So if I have e to the x equals 7, how do I cancel? I have an exponential thing. How do you cancel that? What's the inverse? You got to take a log. With base e, I specifically need to take the natural log. So with my inverse properties, those will cancel. Of course, whatever I do to one side, I also have to do to the other. Keep your equation balanced. So we end up with x equals natural log of 7. There's our solution. Remember, I know natural log of 7 looks gross, but it just represents a number. You can punch it in your calculator. Next example. 4e to the x equals 8. Make sure we're isolated and written in an appropriate form. E to the x, that's the only thing that has an exponent applied to it, so that's what I want to isolate. Is that term isolated? No, because this 4 is hanging out of the way. So how do we cancel that out? Divide both sides by 4. So we end up with e to the x equals 2. Now I'm isolated, I'm in an appropriate form, I have to cancel out so I can solve for x. What's the inverse of an exponential thing? It's going to be a log thing. In this case with base e, I'm going to take the natural log of both sides to cancel that out. Whatever I do to one side, I also have to do to the other. So we end up with x equals natural log of 2 for our solution. Next one, natural log of x equals 4. Here I'm solving a log expression. So I want to isolate my log term. In this case, natural log of x. No rearranging needed here. So now I have to go ahead and start canceling some stuff out. So how do I cancel out or undo natural log? Yeah, do the inverse. So I'm going to raise it as an exponent. What's my base for natural log? E. So what's my base of the exponential thing going to be? E. So I make that an exponent. E to the natural log of x power equals, make sure we do the same thing to this side, e to the negative 4th power. Inverse property, these will cancel, so that's how we get x by itself. X equals e to the negative 4th power. I know that looks gross, but it still just represents a number. Next one, another log equation. Make sure we're isolated and in an appropriate form. Isolating my log term. First, I have to get rid of this 4. So I divide both sides of my equation by 4. Now I have log base 2 of x equals 4. Now I want to get x by itself, so I need to cancel out that log base 2. What's the opposite or inverse of logs? Exponents. So base 2, the log base 2, will cancel to get x by itself. Again, whatever I do to one side, I have to do to the other. So now I take base 2 and raise it to the 4th power. Well, what's 2 to the 4th? 16. So there's my solution there. All right, go ahead and pause this for now and take a second to try to do these 2 problems on your own. When you're ready, unpause the video and check your answers. All right, so the first equation, we saw we satisfied the 1-to-1 property, having log base 8 on both sides. So if we just take whatever we were taking the logs of and set those equal to each other and solve just as we would for algebra 1. The next one, not so simple. We had a common log, remember, which is base 10. So if I have log base 10, I have to cancel that out with exponential base 10. So I took base 10 and brought everything else up in the exponents. So Exponential base 10 and log base 10 cancel, so we end up with x minus 3 equals 10 squared, which is 100. Add 3 to both sides, x is 103. Right, please work on these practice problems on your own on a separate sheet of paper. Go back and reference the video if you need to, and please make sure you turn these in at the end of class. Next time I see you, I'll take some questions and we can go over some of these things, especially for what you have on your homework.